How does EPA specifically reduce chronic inflammation? Imagine a complex network within your body that constantly works to keep you healthy by fighting off threats and repairing damage. When this system becomes overactive or imbalanced, it can lead to persistent inflammation that contributes to conditions like heart disease, arthritis, and metabolic disorders. Understanding how a specific nutrient can influence this process offers valuable insight into maintaining long-term health. Eicosapentaenoic acid, commonly known as EPA, is an omega-3 fatty acid primarily found in fatty fish such as salmon, mackerel, and sardines. Once ingested, EPA integrates into cell membranes, altering their composition and fluidity. This integration plays a crucial role in modulating inflammatory responses at the cellular level. One of the key mechanisms by which EPA reduces chronic inflammation involves its competition with arachidonic acid, another fatty acid present in cell membranes. Arachidonic acid serves as a precursor for pro-inflammatory compounds called prostaglandins and leukotrienes. When EPA is abundant, it competes for the same enzymes involved in producing these inflammatory mediators. As a result, the production shifts toward less inflammatory or even anti-inflammatory compounds derived from EPA, such as prostaglandin E3 and leukotriene B5. Furthermore, EPA influences gene expression related to inflammation. It activates specific nuclear receptors that suppress the expression of genes responsible for producing inflammatory cytokines like interleukin-6 and tumor necrosis factor alpha. By downregulating these cytokines, EPA helps dampen the inflammatory signaling pathways that contribute to chronic inflammation. EPA also promotes the formation of specialized pro-resolving mediators, including resolvins and protectins. These molecules actively facilitate the resolution phase of inflammation, encouraging immune cells to clear out inflammatory debris and restore tissue homeostasis. This process prevents the prolonged activation of immune responses that can damage tissues over time. In addition to these biochemical actions, EPA can influence immune cell behavior by reducing the activation of cells such as macrophages and T lymphocytes, which are involved in sustaining inflammatory processes. By modulating their activity, EPA helps prevent the escalation of inflammation that characterizes many chronic conditions. In summary, EPA reduces chronic inflammation through multiple interconnected pathways. It alters cell membrane composition to favor anti-inflammatory mediators, shifts the balance of inflammatory compounds produced, modulates gene expression to suppress pro-inflammatory signals, and promotes the resolution of inflammation through specialized mediators. These combined effects contribute to a healthier immune response and may lower the risk of inflammation-related diseases over time.